When you see a reflection in the mirror, it looks like there's another you in that mirror, and that they are perhaps behind the mirror, almost as if a mirror is a piece of glass where you're looking into another room, and there's another person identical to you looking back. But is that really the case? If there is an image of a person in the mirror, where is it? Is it on the surface of the mirror? Is it behind the mirror? And where? And does that location of that image depend on the location of the camera or the person who is looking? Well, we're going to try to answer all these questions. So before we start, just a few basics. We can tell just by looking if two things are occupying the same space based on how they move relative to each other. So I have two pens standing on a piece of paper. One is black and one is a pretty funky design. And if I move the camera left and right, which is equivalent, of course, to moving your eye, you can tell that the black pen moves a lot more than the funky pen. And that's because, as you can see, the black pen is closer. If both of these pens were at exactly the same distance, then as I move the camera, they would move exactly the same. So let's take a look at a reflection in a mirror. If I move the camera back and forth, you can see the pen and you can see its image in the mirror. Now note that the image and the pen must be in different locations. That's because they move differently when I move the camera around. So our goal is then to find where that image is actually located. So maybe the image of the black pen is right on the surface of the mirror. I've set up a demonstration to test if that's true. I put the funky pen right on the surface of the mirror. So let's go test it and see if the image of the black pen and the image of the funky pen move together, as they should if they're occupying the same space. Ready? Here goes. Back and forth. Now, I think you can see pretty easily that the funky pen and the image, i.e. the reflection of the black pen in the mirror, do not move the same way. So wherever that image is, it's not on the surface of the mirror. For my next guess, I put the funky pen way in the back. So maybe the image is very, very far away. Let's test this out. Go, get them all lined up. That doesn't seem to work either. The funky pen and the image of the black pen are moving differently. Let's try something else. This time I've put the funky pen the same distance behind the mirror as the black pen. Let's see, and I put it right in a line behind it. Let's see if that works. Here we go, back and forth, back and forth. I think you can see that the image of the black pen and the funky pen move exactly the same. In fact, this makes it look like the funky pen's bottom is in fact the black pen. This means that the location of the image of the black pen is at the location of the funky pen, which is the same distance behind the mirror. Question: does the location of the image depend on the location of the viewer? Well, if I move this back and forth, the image location is the same as the location of the funky pen, and the funky pen is not moving. It's just sitting there the entire time. So the location of the image does not depend on where it's being looked at, which makes sense. Things are where they are, no matter where you look at them or if you're there at all. So here's a scenario that comes up a lot. You have an object, in this case the black pen, and a mirror, and you're asked to find, say on a test or quiz or homework assignment, the location of the image. And how do you, in practice, do that? Well, first, you're not going to have actual objects. The paper is going to look like this. It's going to have a line for the mirror, and it's going to have a little dot for the object. And you're going to be asked to find the location of the image. And what you want to do is just take a normal ruler and line it up so that it's perpendicular to the mirror. And if I just line this edge up right exactly there and then move it over to the little dot, now I can go and read the distance, how far away the object is, and then just measure out that same exact distance right here, making sure to keep this line right here. A lot of people find it helpful to draw a connecting line like this. It's hard to do with one hand, but just to draw a connecting line like that. And then if these two distances are the same when you measure them, then your image will be right about there. Piece of cake. All right, to sum up, my image is actually located on the other side of the mirror. In this case, it's behind the wall in the next classroom over. Of course, you wouldn't see anything there because all the light is bouncing off of the mirror, but my image is located behind the mirror, the same distance away that I am from the mirror. And just to show this to you, I'm going to have myself and my image perform a helpful task. I am going to measure myself, so I am exactly 1 meter away from the mirror, and lo and behold, my image is very nicely doing the same exact thing, and he is exactly 1 meter away from the mirror, so we're both the same distance away. And there you have it.